Section 12.6 is on expectation. So the topics we're going to cover in this section are expectation, and then we're going to look at some business applications of expectation. So let's start off with just a very generic example here. It says, suppose a barrel contains a large number of balls, half of which have the number 1000 painted on them, and the other half of which have the number 500 painted on them. As a grand prize winner of a contest, you get to reach into the barrel, blindfolded of course, and select 10 balls. Your prize is the sum of the numbers and the balls in cash. If you are very lucky, all of the balls would have $1,000 painted on them, and you will win the $10,000. If you are very unlucky, all of the balls will have 500 painted on them, and you will win $5,000. Most likely, however, approximately one half of the balls will have 1,000 painted on them, and one half will have 500 painted on them. That's because half the balls were 1,000 and half the balls were 500. So it says the amount of your winnings in this case would be 5 times 1,000 plus 5 times 500, or 7,500. Because the 10 balls are drawn, your amount of the winnings per ball is 750. So I want you to look at this value right here, this 750 value right here. This is called the expected value. What is an expected value? An expected value is what will the average be in the long run. Notice $750 is not a single ball. The option is either 500 or 1,000. 750 is not an option. This is just if you do this many times, what's the average? So if you do this many times, the average is that you earned on average $750 for every ball that you pulled out. Okay, so again, expectation is not what happens in a single term, it's what happens on average in the long run. So it says the number $750 is called the expected value or expectation of the game. You cannot win or draw 750, but if given the opportunity to draw many times, you will win on average per ball. So it says we can also calculate expectations by using probabilities. For the game above, one half of the balls have the number 1,000 painted on them, and one half have the number 500 painted on them. Therefore, the probability of 1,000 is one half. The probability of 500 is one half. The expectation is calculated as follows. Expectation equals the probability of winning 1,000 times 1,000, and the probability of winning 500 times 500. Remember that the probability of 1,000 was one half, and the probability of 500 was one half, so they get these two values, add them together, and they end up with the 750 that we ended up earlier. So I want you to take this concept. This is with half the balls being 500 and half the balls being 1,000. I want you to change it up a little bit. What if I told you that 1/4 of the balls are $1,000 and the rest, the remaining 3/4 of the balls, are $500? How would that change this up? Well, we couldn't say that if you were grabbing 10 balls, same exact situation, we couldn't say of those 10 balls that we would expect 5 of them to be 1,000 and 5 of them to be 100. We have to change this up, and so that's why this expectation formula works a little better. So what's the idea of what we're going to do now that we've changed the problem? To find the expected value, what we need to do is consider what's the probability of getting 1,000. So the probability now of getting 1,000 would be 1/4. How much would you win? And that would be $1,000. It's a positive number because it's a win. So then we'd have plus, what's the probability of getting 500 would be 3/4 times how much do you win if you get 500? You get $500. Again, the expected value here is a dollar amount. It is not a probability. It is a dollar amount here. So go ahead and put that in your calculator and see what you get. I'm getting an expected value of $625. Again, this expected value is not what happens on one time. This would be if I did this many times on average, how much would I get per ball? So if that's $625 on average, and I did that for 10 balls, if you do 625 times 10, in this situation, I'd be expected to get $6,250. Again, that's the 625 times 10. So when you get the expected value, that's on average per ball. So that's what expected value is. It's not what happens in one event, what happens in multiple events. How you calculate expected values is you're always going to do the probability the event happens times the outcome of the event. If it's a gain, the number is going to be positive. If it's a loss, the number is going to be negative.